minutes. We'll just allow interested individuals time to log into the session. So please do give us about 3 minutes and we'll start at 6:03. I'll post the same in the chat as well. Okay. Hi, good afternoon. And once again, thank you so much for making the time to dial in for today's session. Today, we will be discussing wind optimization, which Aina Karuma from the Daures Green Hydrogen Village will take us through. If I may, just a bit of housekeeping and also just a bit of a discussion around the concept. So this is the second session which the Daures Green Hydrogen Village is hosting as part of its seminars or podcasts titled Going Green, the Daures Journey. And the primary intention behind these sessions is to, provide opportunities for Namibians to get a glimpse into the development of green hydrogen projects. And the ultimate purpose and hope, at least from our end, is we hope that we help encourage some of the next green hydrogen projects that will eventually come live within the Namibian market. So please do feel free to post any questions in the chat. We intend to have a 45-minute session where Aina will just go through the pack. So this is to go through the pack, and then towards the end, we'll open up for any questions or discussions, should there be any. Okay, and then Aina, I can hand over to you. I'll moderate and pause you should there be anything burning in the chat that may be pertinent to a slide you're on.
Good evening. Can everyone hear me and can you see my screen?
So I can hear you loud and clear, and we can also see your screen. I think I'm ready to proceed.
Okay, so good evening and welcome back to the people who are joining us for a second time, and to the people who are joining us for a first time, welcome. Thank you all for taking out time out of your busy days to join us today. So in our previous session, we touched on solar power and the hows and the whys in terms of it being incorporated into the production of green hydrogen. And during our first session, we had a question from the audience that asked us why we couldn't just use solar power alone to power this production or this project. We wish we could, but the sun only shines during the day, so at night, power is still needed. So the wind power supplements solar power because the battery technology that stores the solar power that's harnessed during the day is far too expensive for it to be the only alternative to additional renewable energy power sources. So with this, we will now get into the second session that will focus on wind power. For the people, okay. We just admit a few people. Okay, so for the people who do not know what green hydrogen is and what the importance it has, what importance it has. Green hydrogen is hydrogen that is produced by splitting water into hydrogen and oxygen using electricity generated by renewable power. The standards that are set by the Green Hydrogen Organization state that green hydrogen is hydrogen produced with an emission limit of 1 kilogram of carbon dioxide per kilogram of hydrogen taken as an average over a 12-month period. Okay, so the importance of green hydrogen lies within the pursuit to decarbonizing specific sectors, such as the transportation sector and the concrete and the steel manufacturing sectors. So these are some of the sectors that emit a lot of global greenhouse emissions, as seen in the figure on our presentation. So in 2020, the energy sector was responsible for 73.2% of the global greenhouse gas emissions. And in order to reach the Paris Agreement's objectives of limiting the global temperature increase in the century to 2%, we had to find alternatives to the power or the fuel that's needed to fuel these different sectors. And this is where hydrogen comes in play. So this is a project overview. This is our project overview. And as we can see with the first pointer, the renewables. And this is where our focus is in the beginning of the seminar, where we're focusing on the production of the electricity that is needed to run these facilities. And since we already focused on solar, we're focusing on wind now. So energy systems have a specific design for their concepts and their different stages. We have our energy demand. So with our energy demand, we have to look at our load assessment. And when we say load assessment, we just mean these are the devices that require electricity. So how much electricity will these devices and this equipment require? And after that has been assessed, we can now say that we need this specific amount of power. So once we've concluded with our energy demand, we look at our resources. With our resource assessment, we look at the wind that is available on site and we see how much power that wind could generate and if that power would be enough to power our project. Then we look at the description and the selection of the technology, which is a very important part of this whole process, because depending on what technology you use, you're going to have different efficiencies and different capacity factors. And you have to choose a technology that is cost efficient for your project as well. And then we look at energy storage. And then we also look at a selection of the balance of system components. So the balance of system components is just everything that has to do with the project in general, which means it's all the equipment, all the construction and everything. And then we also look at the costing. So what is wind power? Since we're focusing on wind, you should know what wind power is. So wind is a form of solar energy. The uneven heating of the atmosphere by the sun and the irregularities of the Earth's surface and the rotation of the Earth causes winds. So during the day, the air above the land heats up faster than the air above water. So the warm air above the land will expand and it will rise, and the heavier air, which is the cooler air as well, will rush into the empty space, and this process creates wind. So at night, the winds are reversed because the air cools more rapidly over land than it does over water. So wind flow patterns are altered by the Earth's terrain, bodies of water, and vegetation. And wind power is the use of wind turbines to create electricity. So this is how we harness the wind's power. We harness it through the use of wind turbines. For our wind development process, it's a very lengthy process and it takes a few years for this entire process to follow through. So at first, we look at prospecting, which means you are finding available land that has the resources that you need. So once you found the land that you need, you look at the land leasing and you also review your resources. And this takes about 2 years. And then after that, also, you also have it takes around 6 to 9 months where you have to um, look at your counterparty contract negotiations, which has to do with the power offtake and the equipment providing and the O&Ms. And then for a range of 3 to 9 months, you would be seeking finance because wind projects are very expensive. And for an additional 6 to 9 months, the construction and the project commissioning happens. And then the project operation can happen for up to 25 years. So when it comes to the land control, which is under the land leasing, land rights are needed to build a utility scale wind project. And these can be acquired through easement. This is when you have an agreement between two parties where one is granted land access in exchange for a fee, or you could lease the land, or you could get it through a title depending on the project location and the owner of the land. With the wind resource analysis, which is under the resource review, this step would determine if a potential site has sufficient wind resources and to project the amount of energy it will be able to produce in order to determine the size and economic viability of the project. When it comes to the permitting of the land and just the project, if any permits are required for the construction of the wind project, then they should be applied for. And then there's also the interconnection process. So if you wish to sell off your electricity produced by your wind power, new transmission lines would be required to reach these utility substations. And then there's also your PPA and your financing. So your PPA is the power purchase agreement. And this is a financial agreement, a power off-taker that specifies the terms under which electricity is produced at the wind project will be sold. So in most cases, when it comes to financing, the financiers needed to pay for the costs of the developing and the constructing of, it's needed to pay for the developing and the constructing of a wind farm. But most potential lenders would like for there to be a power purchase agreement in place. So they know that once this wind farm has been built, someone wants your energy. Someone wants the electricity. There is going to be someone who would be purchasing your electricity. So another step in a wind development project process is the environmental review, where an EIA, which is an environmental impact assessment, it has to be carried out to evaluate the project's impact on the natural, cultural, or historical resources and wildlife. And this is also inclusive of the visibility of turbines within a broader landscape and also the detrimental effects on vulnerable species and the potential for disturbances of any heritage sites within the area also has to be taken into consideration. So the habitat and the migration paths of birds and bats must also be taken into consideration when this EIA is being done. So within this project as well, we also look at the EPC. So our EPC is our engineering, procurement, and construction. So most project developers will hire EPC firms to perform specific tasks for them. This includes the designing and the engineering and the procurement and a bunch of other things. So when it comes to the engineering, the site survey feasibility study, which includes a full-length design of the wind project, including the number and the arrangement of the turbines, as well as the buildings and roads that will be used for the operations and maintenance activities, are handled by the engineers. So for the procurement, it's when the purchase of all your physical equipment and materials and the hiring of all labor required to complete the wind project. So the timing of the procurement activities impacts the total cost of the project as well, because if your equipment is delivered earlier, then you would also have to be paying for storage costs. And if your equipment is delivered later, then this would cause a delay in your construction. So the transportation and delivery of wind project materials can be complicated due to the large sizes of wind components. But this transportation is usually handled by logisticians. So for the construction, in the construction phase, the turbines are installed and all the supporting infrastructure is also built. And multiple companies are involved in the construction, and most of the time they hire subcontractors because they can't do everything. So there'll be subcontractors for, say, the electrical systems and other subcontractors for, say, the roads. So for the labor, there's a diverse group of and highly skilled laborers are needed for a wind project, like land acquisition specialists. These are people who are responsible for acquiring the land for the wind sites. And then you need your wind resource specialists or your energy specialists. And these people assess the suitability of a location for wind energy production. And then your environmental scientists are the ones who perform your EIA, which is your environmental impact assessment. And then your engineers will design the placement of the turbines and the supporting infrastructure. And your procurement specialists, sorry. Oh, my voice. Sorry. So your procurement specialists, they usually arrange for the purchase and the delivery of all the necessary equipment and materials. And then you also just need your general and specialized contractors. And these people are the people who are going to be assembling the wind turbines and also constructing the supporting infrastructure. And then your logisticians are the people who are going to be helping you keep transportation of the large turbine components as efficiently as possible. So wind turbines. Wind turbines convert the kinetic energy in the wind into mechanical power. A generator then converts this mechanical power into electricity. So some of the major components of the wind turbine are, there's the rotor, usually have 2 to 3 blades, and these are the components that convert the energy in the wind into mechanical energy using the rotor shaft. So your gearbox is there to match the slowly turning rotor shaft to the electric generator. And then you have a tall tower which supports the rotor high above the ground to capture the higher wind speeds. And then you also require a solid foundation to prevent the wind turbine from blowing over in high winds. And you also need a control system to start and to stop the wind turbine and to monitor the proper operation of the machinery. So with your wind speed measurements, wind speed is one key to having a viable project. So wind met masts are used to measure live wind speeds on the chosen sites. And these wind measurement campaigns take at least 1 year. You also need these wind measurement campaigns so your project can become bankable. So the measurements are done at respective hub heights. An acceptable standard would be to measure the wind speed at 75% hub height. So if, say, your wind turbine is at 120 meter hub height, then your met mass would be at, say, even 90 meters. So the met mass should be placed in the best wind spot, the worst or median wind spots on site. So you can also tell whether your location has good winds by looking at the vegetation that is on site. So the vegetation can be used to determine your wind direction and the wind intensity in an area. So we call this flagging, the way in which your vegetation would be set up due to high winds and constant winds. As you can see from this picture with the tree that's to your right, you can see that it's deformed in a way. And if you compare it to this image right here, you can see that it's undergone partial throwing. So with partial throwing, you can see that the wind speeds would be at around 7 to 8 meters per second. So you can use the vegetation to tell whether your site has high winds or low winds or moderate winds, and you can see whether it's suitable for a wind farm or not. So Namibia and wind turbines. Namibia does not manufacture wind turbines. All the wind turbines that are used or are to be used within the country are usually imported, or they're always imported. And the import of wind turbines requires the skill sets of logisticians. So due to their size, wind turbines are imported in parts and then assembled on site. Because you also have to take into consideration the sizes of your roads. These wind turbines are very big, especially the rotors. The rotors take up a lot of space, and then the hubs as well. They're just very large in general. So those required for the maintenance of wind turbines include electrical and mechanical skills. So the TVET schools and universities would be required to upskill their students with knowledge of turbine maintenance and assembly in order for the country to produce in-house wind technicians. So this will aid in the country's efforts to increase capacity building and skill retention. So the wind resource in Namibia, so the high and constant wind speeds which offer the ideal conditions for the construction of wind power plants are found above all on the south coast in the region around Lüderitz. That's where the highest wind can be found within the country, but high wind speeds can also be found in the coastal region on the border to Angola and the coastal areas in the northern areas of Namibia. So in terms of our site, we had a desktop study done by GeoNet. We commissioned that study so we could see whether our site had suitable wind speeds or not. And with our desktop study, it was found that our site at a hub height of 120 meters, the average wind speeds were reaching up to 7.6 meters per second, which is a very high number. But also in-house, when we did our own analysis of the site, we found that our wind speeds would be around 8.4 meters per second, which means we'd actually be able to generate much more power than we had initially thought. So like I had said before about the engineers being in charge of the placement of the turbines, here you can see that there has been some micrositing that has been done on our site. And the micrositing was positioning 100 turbines, and the proposed turbines that we were using were, say, 5.9 megawatt turbines. So with 100 turbines, we would think that would be generating approximately 590 megawatts. But this micrositing is for our fourth phase, so it's for when we eventually upscale. And these turbines are usually placed a distance, a minimum distance of 4 to 6 times the rotor diameter. And for our wind site optimization, so we used a Bloomberg terminal for this. It's called the Wind Farm Capacity Factor tool. So with this wind capacity factor tool, you can put in the coordinates of your location, any location, and you can choose which turbine make you'd want to use and which turbine lane you'd also want to use, and the hub heights and your losses, and it will generate the capacity factor and also give you, it will also output the generation output over a specific period of time. So there are about over 500 different turbine makes. So, and even if the turbine that you want to use within this tool is not there, you can also add it yourself. Yes, can everyone please just mute their mics? Sorry about that disturbance. Okay, so with this wind capacity factor tool using, say, we can call this turbine 1, we can see that our net capacity factors were around 44%. And for those who don't know what your capacity factor is, the capacity factor is the ratio between what a generation unit is capable of generating at maximum output versus the unit's actual generation output over a period of time. So this just includes all of the losses that you would encounter when you're trying to generate electricity, the same way you'd also be incorporating your losses into your solar farm. This is just another picture of our site that indicates that we have vast and open land that is enough to house all these wind turbines that we'd actually like to erect in the future. Yes, so this is the end of the first part for our wind series. There will be a second part in the future because I felt that the information was far too condensed for just one session, and not everyone can take in all that information at once. So for now, I'll leave the room open for any questions that the audience might have. Jerome, you're muted.
No, sorry. Okay, sincerest apologies. Thank you for that, Aina. So the entire premise for the sessions which we are hosting is, one, to provide laymen or laymen individuals with an opportunity to get to grips with some of the technical aspects, but also to take individuals through the journey. So we can now open up for some questions. As Ina mentioned, we'll have a second wind session in probably about another 3 to 4 weeks, where we will be discussing optimization from the perspective of solar turbine models, capacity factors, how, the selection of solar turbines and so forth. Ina, there is one question here, and if you could perhaps maybe go to the slide on the project configuration, the slide that has the graphical flow of all the items that will be taking place on the project site.
Is it this slide?
No, the graphical flow that shows the various stages within the Daures project. There you go. Okay, so one of the questions received is from Phil, and Phil is essentially asking if it's possible to have a self-powered hydrogen generating electrolyzer that would run on itself in perpetuity. And I think this relates to, step one that we're looking at, where we're currently discussing the renewable energy generation portion and how that would, in effect, power what is being reflected right now as step 4. And I must say, Phil, to my knowledge, I've actually not seen anything in the market that speaks to an electrolyzer that can perpetually power itself and produce more hydrogen with the hydrogen that is currently being produced. I take it that's the overall gist of the question. I've not seen any technological solution that speaks to offering something of that sort. But what what I can say is, with the general construct of these types of projects, and in essence, the terminology of it being green is on the back of making use of renewable power to power the production of hydrogen. Okay. Phil, I hope that assisted. I do see we have a hand up and another question in the chat. Perhaps we can take the hand and then address the question in the chat. Please do feel free to unmute and ask your question or comment. Mr. Chakula, please feel free to unmute.
Okay, good day. Can you hear me?
Yes, can hear you.
Okay. Okay. Thanks, Aina. Thanks for the insightful presentation that you've just given us. My question is basically on. I just wanna find out what technology are you guys just focusing on onshore wind energy, or do you are you doing both offshore and onshore energy? Because I understand, I think if you look at the southern or the SADC countries, I believe we still don't have offshore wind energy. Is there a specific reason for that, or is that something that Daures might do some exploration and try to move into that market?
Okay, so for our project, we'll only be focusing on onshore wind energy. Yes. So in terms of the offshore energy, there isn't any within the African region, but then our wind capacity factors for the offshore wind is much higher than the onshore winds, but because of the environmental impacts that are associated with offshore wind, I don't think it's a market that we should be going into at present. And there are still studies being conducted on offshore wind as well.
Okay, so you're basically saying the main challenge is actually the environmental factor at the moment.
Yes.
Oh, okay.
Okay. An additional question. This is from Amanda Basson. The question number one being, with green hydrogen being subsequently very expensive energy source to transport and store, what is the delta electricity in terms of cost for the end user of current centralized distributed energy and renewable distributed energy? That's question number one. The question further extends, is there an analysis there too, or a feasibility study? And then the second question is, from an investment point of view, what is the distribution process like in terms of selling electricity sourced from this wind PV? Does the investor come in through a PPA or ESCO SPV? And what are these various frameworks in relation to ESG? Okay, so I'm happy to attempt to answer some of these questions, and I'll be forthright in admitting where I feel some of the questions may be a bit beyond our scope, as well as the scope of the present session. So that being said, with respect to question one on the end user cost for the energy, as you know, the price of electricity is regulated, and if we are talking about distribution through, the existing frameworks, I'm not too well placed to answer that question with respect to that. The second portion of the question is with respect to an investment point of view, what is the distribution process like in terms of selling electricity sourced from this wind PV? So it would work similarly to what you have in place for, say, your solar. Of course, it would be potentially on the back of, say, a PPA. And then, of course, investors would potentially, participate in some sort of SPV, which would allow for the establishment, or the financing of this wind energy, which is generated. And then question three, what is the ESG frameworks scopes that the Daures Green Hydrogen project complies to? Okay, so of course, with respect to ESG, I think, looking at the environmental sustainability and governance on, on the Daures portion, I think it's quite clear that the project is definitely, ESG compliant. I think one of the big things with respect to ESG is what is environmentally sustainable. This project is going to be based 100% off of renewable energy, and in fact, it aspires to be Africa's first net zero village. So all in all, the project would definitely comply by most ESG frameworks and scopes. But with respect to particular policies drafted around the ESG portion, this is unfortunately also still in progress. Okay, we do have a question from Klaus, and the question is, how many jobs are going to be created through the operation of wind farms? Is the Daures Green Hydrogen Village going to be employing Namibians, and is there capacity? And then secondly, are wind turbines running throughout the day and feeding into the grid? So Aina, I can answer the first half of this question, and I believe you can probably answer the second portion. So during operations, in total, the Daures Green Hydrogen Village in its phase 1 pilot aims to employ up to 50 Namibians, and this will be in various aspects of the operations, not solely related to, say, energy generation or wind energy generation. The intention is to employ as many Namibians as possible. We've actually in the process of negotiating with our preferred contractor on the construction side for the construction of phase 1 of the pilot. And one of the requirements there is, of course, that 50% of the employment in the workforce should come from the Daures constituency. So I think it shows, overall commitment to try and employ as many Namibians as possible. Of course, issues around capacity have been identified as recently as, I believe, last week. The Namibian government, in partnership with the German government, announced scholarship funding, which should assist with the further development of capacity of these various industries which are in development. And then, Aina, perhaps you can just give some guidance on whether these wind turbines will be running throughout the day and feeding into the grid.
So with the time series analysis that we did in-house, it shows us when the wind would be blowing and at what intensity it would be blowing. So we can see at every single hour if the wind would be blowing or not. But there are specific times within the day where the wind isn't blowing, or it might be blowing, but it's not blowing fast enough for it to actually make a difference in terms of generating energy. So no, the wind turbines would not be running 24/7. There will be some times when they're not running. So when they won't be running, to supplement this loss of energy, we will have to be using batteries. And these batteries would have stored the power from the solar energy. And also for the other part of the question, we will not be connecting to the grid because our grid is not green, so we will not be feeding into the grid at all. And in order for us to still be producing green hydrogen, the power sources have to be green.
Okay. I see Amanda's hand is up. I think, Amanda, if you'd please do feel free to unmute and ask your question.
Hi, everyone. Can you hear me?
Yes.
Yeah, hi. Thank you so much for answering my questions earlier on. Maybe I could just elaborate because I didn't really understand your response in terms of my first question. And mind you, I'm not really a specialist within the field of green hydrogen, so I'm also just learning, and I just want to know. For the first question, in terms of the delta, what I mean by that is, did your project, or did the Daures Green Hydrogen project do a feasibility studies to see in terms of, okay, fine, if anybody wants to, as an investor, if anybody wants to sell this green hydrogen as electricity to an end user, what would then be the difference be in terms of, for an investor from a cost perspective, between electricity being sold at the cost that it is being sold at right now, against to what it would be sold if it was sold as clean energy?
Okay. Thank you for the question. I do understand the question. No, Amanda. So for all intents and purposes, I mean, our energy that would be generated would be sold or would be distributed in the form of, say, ammonia, which would most likely be the energy carrier. And then, of course, at its end destination, this ammonia would then be converted back into hydrogen. So on our end, for a project like this, we would actually be looking at what would a price point be per ton for, say, hydrogen or green ammonia, as opposed to what would the electricity rate be for the end user should this eventually become a method through which energy is provided for, say, let's say, residential or corporate users. So unfortunately, I don't have an indication of what that price point or cost point would be, But often some of the topical conversations that you would see in the green hydrogen space, in some of the other markets are identified price points that would put green hydrogen as being price competitive. For example, with sources of energy from energy derived from sources which are not carbon neutral. And it's a bit different when you look at some of the export markets in relation to, say, the Namibian market, because of what the composition of some of these energy grids are. For example, in Namibia, it's not as you don't have as many various forms of energy within the grid, whereas compared to, say, Western markets, you start to talk about items like, say, gray hydrogen, which is currently potentially used in some industries, or LPG, so on and so forth. But within a Namibian context, I don't believe this type of study has been done.
All right, thanks, Jerome. And just before I go, in my second question, so if as an investor, just hypothetically speaking, would the investor then go into a PPA agreement? Is it with in terms of distribution towards the end user, getting the energy source now from Daures Green Hydrogen? Would the investor then get into a PPA agreement with the Daures Green, or would there still be another SPV in between? Like, how does that process? How would that work?
I think this question's a bit more complex. I think we probably need a bit more of a conversation behind it, because I think you're looking at it. I could answer this from two different perspectives, at least in my point of view. I will pop my email in the chat, and please do send me an email, and maybe we can just have a call.
All right, that will be great. Thank you so much.
Okay. So then the next question was from Michael Petrus. His question is, how has Namibia prepared itself for the utilization of hydrogen which is going to be produced? Do we have the technology to utilize the hydrogen, or are we only going to be exporting it? I can take that question. So Michael, I think, the onus is on us within Namibia to develop these various use cases where hydrogen can be applied as an energy source. Of course, so this is something that I think everyone, or firms that aspire to, be in the industry should be looking at. On our end, it's definitely items that we are looking at with respect to local usage of green hydrogen, and this can be in various forms. For example, say decarbonization of, say, mining processes, for example. But the onus would still be on Namibians. You'd be getting actively involved in attempting to business case some of these solutions, and develop these local use cases. But I believe that this is also something to be addressed, and we hope to evidence some local usage of green hydrogen as well in the project. And I believe it's also important to note, green hydrogen, with one or two more additional processes can result in green ammonia, and ammonia is a key chemical which is used in the production of a lot of goods and services which are readily used in the Namibian market. And I think then when looking at the ammonia side, there's definitely opportunity for local usage. So I do not believe that the intention is only to export it. In fact, locally, as Daures, we are also looking at various options and usage or use cases for green hydrogen and green ammonia. And then lastly, I see there's still one more hand up. We do have about 8 minutes left. Phil, please do feel free to unmute and ask your question.
Good evening. Can I be heard?
Yes.
Okay. Thank you for such an intellectual, appealing presentation. My question actually lies to the scope of environmental impact assessment. Now, is each phase going to have a separate environmental impact assessment, or will it be done, or was it done collectively?
Yeah. No, you're correct in the assertion. Each phase will have its various environmental impact assessments. There may be opportunity to try and consolidate, but of course, you wouldn't want an endless scope. So it would be looking at some of the cost benefit factors with respect to, you know, expanding the scope of one EIA to accommodate probably a subsequent phase. But yes, each phase will have its own EIA assessment.
Okay, thank you. My question was answered. And also one more suggestion, is it possible for me to get this presentation, or not literally the presentation, but like the whole session and stuff?
In terms of the presentations, if anyone is interested, they can just email me. Jerome will put my email in the chat as well, and I will share the presentation. And with these sessions, they will be uploaded onto our YouTube channel. And I also see, I think his hand is down, but Sylvester had his hand up for a while. Yes, there he is. Sylvester had a question for a while, so.
Good evening, everybody. Can I be heard very well?
Yes, yes.
Okay, this is in regard with the ammonia. When you were talking about ammonia, I was actually feeling happy. I'm also one of the, should I say, leading supervisors at Swakop Uranium. So we are also importing uranium, not uranium, but we're also importing ammonia. So your project may assist us a lot for us to cheaper way to get ammonia for our production in the process plant. That is one. Maybe you should also consider us supplying us ammonia in the near future. The second one, the water. What are your plans for getting water? Is it the drill holes, or will you be able to build desalination plants? That was actually my main question.
Yes. So for the pilot first phase, we will be using borehole water. Fortunately, at pilot scale, the water requirements are not intensive. But yes, for subsequent phases, we are investigating various options around the provision of water, of which, you know, the pipeline from existing desalination plant is an option, investigation and feasibility into establishment of a new desalination plant would have to go into feasibility as well. So the water strategy for subsequent phases is still being created and being assessed through various feasibility studies to be conducted.
Thank you very much. That's a good one. And another one, the social responsibilities for the community around that area. Is there plans for that as well? Did we have discussions with the conservancy and the traditional authorities and all those?
Yeah, I think this is a very important part of this project. So, you know, as with what has been widely reported, this project is also owned and partnered with both the traditional authority, the Direct Demand Traditional Authority, and TSIP Conservancy. So of course, CSR stretches far and wide with respect to, for example, aspirations around employment numbers and sourcing of employment from individuals from the constituency. And this is to be done in conjunction and with the aid of both the traditional authority and the conservancy. But then also over and above that, we have had 2 social drives thus far within the Uis area. We anticipate having a third one by the end of this month. At present, we are supporting one of the local orphanages, as well as our next anticipated CSR drive would be for a primary school within the Uis area.
Thank you very much. I'm very happy to hear that. Thank you very much. That was all from my side.
Thank you. Okay, we are running out of time, but I think we can afford one more question. Mr. Chakura, please feel free to unmute and ask your question.
Yes, can you hear me?
Yes.
I believe you mentioned a point where you said you'll be running completely off grid. So I just wanted to find out how are you navigating through the issues of power quality and reliability, as we know that wind energy is what is this? One of the intermittent source of energy. So are you guys considering energy storage or?
Yes, like I had mentioned before, when the wind power isn't sufficient to power our plant, we will be making use of batteries. So we are considering energy storage.
Okay.
Okay. And I think that is a fitting question to end on, because that is exactly what we'll be discussing in our next session, how to, one, further optimize the wind so you have sufficient generation, and then two, how do you deal with some of the intermittencies presented by these renewable energy sources. So that being said, I want to thank everyone for taking the time to dial into today's session. And we look forward to actually hosting a public session for the next seminar where we can, have a public venue and have individuals potentially attend in person. Thank you all and have a great evening.
Thank you. Bye.
Thank you.
Thank you very much.